This is Alex. I'll be explaining lab 4, first rule. The first rule's pendulum is set to be 1 meter. To calculate, to measure the period here in our experiment, we do exactly this. Calculate the periods back and forth motions in 20 seconds, and then divide that number by 20 to get well, to get the period. Um, so and then the reciprocal of that would be the measured frequency. So to get a stopwatch going, and then set it to 20 degrees, I think. Right, that's correct. Amplitude is 20 degrees, and then you just count. I count it for my period. Measure period is 2.022 seconds, and the reciprocal of that is 0.495 hertz. And there's a frequency that that was using in 2 here, using this method to calculate the frequency, which counts the period go back and forth, back and back, so left to right, and then goes back to left. Count the periods in 20 seconds and then divide it by, use that number to divide to be divided by 20 to get that this frequency. Well, to calculate the theory period from theory, you basically would want to use this equation. In this experiment, our gravity is set to be on Earth. So excuse me for that, for my phone. So you would simply use 2 pi times square root of 1 meter, that's the length of the pendulum, divided by g, 9.8, to get well, we got 2.007 seconds. That's the period in theory. And the frequency would just be its reciprocal. It's 0.498. The numbers are pretty close to each other. Excuse me. Numbers are pretty close to each other, and the percentage error, which would be experimental minus theoretical over theoretical, it is times 100. It is as you can see, it's less than 1%. It's 0.95% percentage error.